Hello, we are here for one more lesson of this CAD training course, and the topic for today will be the photorealistic images. So this is the final result that most of the time we want to obtain when we work in one project. So we want to model an assembly or a part, and we need or we want to send an image, a realistic image of what we've created to a customer, to a colleague, to another company, whatever it is. The idea it is after we get all the modeling with all the things we want to apply, we may or we should give textures to the objects. We need to position the lights, everything we've been seeing until now. And after all of this, we need to create the photorealism and to create that image. So for that purpose, Tools menu, and we have this function here, Photorealistic View. And there are three ways to create these photorealistic views and the ray tracing. Okay, the ray tracing is the best one, and it is what we can call the first mechanism, and it is called Pov-Ray. This is a ray tracing program and generates images from a text-based scene description. We have a full description in our theoretical site, so it is good to see how to do it. And this program is a separate installation, so I don't have it also by default, because if I try to run it, I don't have it installed. But the principle is the same as on this one as for the other two. Okay. Besides this one, we have other two. One is what we call the Nvidia. It is the second mechanism to generate these images. And it is used to create high quality images based on lighting and on the material properties such as transparency, refractive and index surface properties, etc. Okay, we can obtain these images directly from CAD, and for that we need to control mainly the quality of what we want. So the third one, it's a photorealistic view and uses something called NBRI, which is a ray tracing kernel developed by Intel. This NBRI uses CPU and provides a high performance and image quality. Okay, they are similar, but Nvidia will be better than this view. Let's try to use this Nvidia option, and we will see how to do this. So as you can see, it's already working. Okay, the time remaining, it is what it left, what remains to end the calculation under the parameters that we have defined. And as you can see, the image refines along the way, because the program is calculating in every pixel the improvement under the conditions that are defined. And when it stops, I will leave this so that we can see the final result. But it is important to see that I have only the standard quality, okay? And I can improve this, I can improve or decrease. And after I can save the image to a file or print the image. Okay, it's something important, because it will allow me to obtain the result, which is the image, and export it in some of these ways. As I was telling, we have the possibility to deal with the parameters and to work on the quality. I will wait a little until the program stops, so that you can see the difference between a standard quality and if I want to improve to the high quality. It will refine a lot, and probably for this kind of image will take a couple of hours to finish. which is quite impressive if we think that in this standard quality the image it's already quite good. So I will wait a little for the program to finish. Okay, it's already in 700 iterations. So as you can see, it continues to refine the elements. 25 seconds to go. Ten seconds, almost done. This is a very high demanding feature from the hardware, so it is quite nice, not perfect, but quite nice for a 2-minute calculation. If I go into image parameters, you see that I have a couple of things that I can work with. And now I will approximate this a little, or I will approximate this a little. I will do again the same calculation, and for you to see the difference, okay, it's already started. I will pause it and I will change. If you see, I have low quality, standard, high, or maximum quality. I am only on the second level. Maximum quality, and I will leave this a little to see the difference. But as you can see, for this image, we have 8 hours, more than 8 hours remaining. So as you can see, for a high quality image, it demands a lot from the hardware and it takes a long time. Okay, there is a big difference from standard quality and high quality. And if you see, not so many iterations yet, but you can see that the quality of the elements, it's improving for each iteration. So we will not wait, as you might imagine, for the almost 9 hours and still increasing the time, so still not decreasing. But this is something that you may imagine that will take long, and in the end it will produce a very good quality image. So to work with this photorealistic generation of images, these are the concepts we have. So if any help is needed besides the things we mentioned on the video, so let us know so that we can support you.